Hello everyone, welcome back to Maths for Machine Learning series. If you're following along, you're slowly building the mathematical foundation needed to truly understand machine learning, not just use libraries blindly. Today's topic is extremely important because without this concept, models like Naive-Bayes, Bayesian Networks, probability classifiers simply wouldn't exist. We're talking about conditional probability and the law of total probability. So, we'll begin. What is conditional probability? So the conditional probability means what is the probability of an event A given that event B has already happened? Think of it like reducing the universe of possibilities. We're not considering every possible outcome anymore. We're only looking at situations where B is true. Now we ask, within that smaller world where B has already happened, how often does A also happen? The formula is probability of A given B equals chance of A and B happening together divided by chance of B happening. We'll take an example of cards. We want to find what is the probability that a drawn card is a king given that it's already known to be a face card. Well, face cards are Jack, King and Queen. There are 12 face cards in a deck of 52. So let event B be that the card is a face card, which means 12 out of 52 possibilities. And event A and B, meaning card is a king from those face cards, the chances are 4 out of 52. Now we apply the formula. Out of all the times we see a face card, how many of those are kings? That gives us 4 possibilities out of 12, which means the final answer is 1 out of 3. So if you know the card is a face card, there's a 33% chance it's a king. Conditional probability shrinks the sample space. Instead of looking at all outcomes, we only look inside the zone where B is true. Then find how much of that zone overlaps with A. This concept is foundational for machine learning, especially when dealing with uncertainties and classification problems. Algorithms like Naive-Bayes, spam filtering, recommendation system and Bayesian inference, they're all dependent on this particular conditional probability, meaning they all rely on conditional probability to update beliefs when new evidence arrives. For example, what is the probability that a particular email is a spam given it contains the word free? This is exactly what conditional probability is. Now, for the next topic, we move on to the law of total probability. Now that we understand conditional probability, we'll look at something that expands it. The law of total probability answers a different question. When there are multiple paths to the same outcome, how do we calculate the total probability of that outcome? We'll take an example again. Imagine a test that identifies a rare disease. So we'll consider an event A, which indicates that the test is positive. So there are two cases. The test is positive because the person actually has the disease, or the test is positive even though the person doesn't have the disease, which is also called as false positive. So the law of total probability combines both of these possibilities, meaning total probability is equal to probability of a true positive as well as the probability of a false positive. We weigh each case by how likely that case is. We'll consider another example. 2 bags. Bag 1 contains 3 red and 2 blue marbles. Bag 2 contains 4 red and 1 blue marbles. We choose one bag at random, then draw a marble. We want what is the probability that the marble is red? 2 ways it can happen. Pick bag 1 and draw red, or pick bag 2 and draw red. So we calculate the chance of picking bag 1, which is 1 out of 2, and the chance of red given bag 1, which is 3 out of 5. Then we'll do the same for bag 2. If we combine them, then we get the total probability as almost 7 out of 10, which means there is a 70% chance of picking a red ball overall. Conditional probability reflects within B how often does event A happen, and the law of total probability reflects if A or an event A can happen through multiple routes, consider each route and add them up. Both concepts are building blocks to Bayes theorem, which we will explore next. And that wraps up for today's session on conditional probability and the law of total probability. These concepts are extremely important in ML, especially when we move into Bayes theorem in the next video, which connects everything we learned today. So if you're enjoying this Math for Machine Learning series, please take a moment to like, share and subscribe. More than 60% of people who watch this channel regularly are unsubscribed. Your subscription motivates us a lot and also supports the channel and helps us continuing making free ML learning content. So thank you for watching and I'll see you in the next video.